Yeah, we're good. Okay. So about 10 years ago, I was a DBA in an ops team in an insurance company. We had our data center based in Gatwick, and every 6 months we used to have this DR exercise where a couple of people from each team would be chosen. You'd be given a couple of weeks' notice, and what would happen, you'd go to spend 2 days at other backup recovery facility near Heathrow, where the idea is the first day you recover the application. The evening and the first day was great. Everyone would go to the pub. It was a great night. It was probably one of the most legendary nights I've had at a company. So everyone used to like doing this. Then the second day we'd get some data, we'd recover the data, and we'd test this applications. So we do this every 6 months, quite a regular thing, and it's quite enjoyable mainly because of this, the night out. What would happen is we'd arrive to our normal office on the first day. We would sit down, we'd start working away. Someone would come over, it was not quite role play, but it's quite exciting. We worked in IT, so this is about the most excitement we used to get. So someone would come along and say, the data centers, there's been a disaster in the data center. You can't go in there, it's been completely destroyed. You go, that data center there? And they go, yep, that data center there. Then you'd be told which application you were going to recover. You jump in your car, head down the M25, hopefully get there in some sort of reasonable time. End up in a SunGuard facility, sign in, and we'd be assigned a cage. So each team would be given their own cage in SunGuard. Has anyone had one of these, been to one of these facilities? Yeah, they're quite cool. I used to quite like it. Not everyone used to like sitting in a cage, but I used to quite like it. You sort of act out your inner monkey, like in a zoo thing. But so you'd be sitting there, someone would come along, they'd have a trolley full of hardware, they'd ask you what cage number you're in and what application you're recovering. They'd give you some hardware, they'd tick off a box, they'd go away. You start plugging all these, couple of servers in. So I was in the SQL DBA team, so we'd have a couple of servers, we'd have some disk to set up, it wouldn't take long. And then a little while later, someone would come along with another trolley with like these plastic containers. And these containers contained everything we needed to recover the application. So it didn't have the latest backups. The latest backups would come the next day by courier. But they had like these printed Word documents. And these printed Word documents had all the instructions, so I'd set my time, all the instructions that we needed to recover the applications. And the instructions were like in ridiculous amounts of detail. So they'd tell you how to eject a CD from a CD drive, how to put a CD in, put it back in again, how to wait a couple of minutes. It would say like right click on the D drive, and if your CD drive isn't your D drive, then go off, and there's another set of instructions on how to find which drive letter your DVD drive was. And then by each drive letter, each D drive, it'd have a little box. So you could go and scribble out the actual D drive, and you could write what letter the CD-ROM drive is. It's like ridiculous amounts of detail. And you didn't have to follow the actual details, but a lot of people did. Now, the way it worked, you'd think that these boxes would get out of date quite quickly. But actually, if you were chosen to go on this exercise, and I'm convinced this is the only reason these boxes stayed up to date, was that if you couldn't restore your application on the first day in a pretty meaningful way, then you weren't going to the pub. That's basically it. And to be sitting in the cage for 2 days with nothing to do, basically, it wasn't a lot of fun. So everyone kept these boxes up to date. We had a change control procedure. We had a little tick box on each change request you made. You had a tick box saying, we're going to affect what's in the box. We're going to make a production deployment. We're going to need to change what's in the box. You'd make your change, that would get completed. The box would come back to the office. Everyone would update it, and they would always update it. And no one in IT ever wants to update documentation, but they were always kept completely up to date. And so we were a SQL DBA team. We had SQL Server to recover. They would have some like VB apps, some Cold Fusion apps. So we were normally in the pub we were normally the first ones in the pub. I quite liked it, it was quite good. Obviously in the evening comes along, have a good time. Next day, courier would come along with the latest tape backups. We'd restore them. Someone from the business would come along, they'd run through a couple of processes, give us a thumbs up or thumbs down. And it didn't really matter if we completely recovered the application or not, but as long as we knew what things were missing, then we'd go through like a retrospective process afterwards to sort of make sure we've updated it and get these applications up to date. And it was really interesting. And originally, I thought, for quite a long time actually, I thought this is all about the data. If we can't recover the data, then there's not a lot we can do. We're basically, the company's ruined. But the more I work with DSC, the more I sort of realise actually the more important thing is the configuration. How do you set up the application? Now, there's ridiculous amounts of details on how to set up an application that gets lost. I think if there was a disaster and the company lost like 6 months of data from everything, like that would be pretty bad. I'm not suggesting anyone does that, like to test out how good your configuration strategy is. I'm not suggesting you test that out, but if you lost 6 months of data, they could hire a big room, get a big room, hire a load of people, and they could recover it. I mean, it's an insurance company, so there'd be fines, there'd be sort of, in the market, it wouldn't look too good, but you could recover from that, I think. But if you had to recover your applications first, and like this company, it was quite an old company, they'd gone through a lot of mergers, like people didn't know exactly how things were set up originally. And if they had to spend 6 months a year putting in the systems in place to then be able to recover some data, I think that's, the company would have struggled to carry on with that. So the more I look at it, the more I look about DSC and things like that, and it's all about configuration management. So obviously keep your backups, but we've now got a better way of managing our configuration for applications. And so I say, this is actually I got quite excited when I realised this. I put these two things together. In 2007, we had, a little bit later, a bit earlier, we had like this printed Word documents. And now, in 2007, we've got MOF documents. Right? If you compile a DSC script, the official term, and it is mentioned on MSDN, is a MOF document. That's exciting? Come on. that is one of the most exciting things that I've seen in IT in a long time. So where were we? Right. So this is the past. This is the present. The future, obviously, is this guy. These are configuration issues, and I don't know if you see his tattoo, but that's Docker. If you can run all your applications in containers, if you can configure everything using containers, then do it. That is the thing to do. That makes life a lot easier. I like this picture. You don't have to use MOF documents. You don't have to go through all this process. Who can run all their applications today in containers? All right, you're in the right place. Okay. So, what we'll talk about in Azure. This is the what we'll talk about is the automation account. So in Azure, there's a thing called an automation account. I don't know how clear this is, but this is if you do a Google search for two-headed beast, right? You'll find this tattoo. I think it's the same person. There's two legs. So Azure Automation account is basically got two parts to it. There's the part that has like PowerShell runbooks. Does anyone use that to like run PowerShell scripts in the cloud? Yeah. So it has that part of it. We're not really interested in that for this talk. We're interested in the second part of it, like the second half of it, that does a load of stuff with DSC. And the DSC stuff is broken down into two more components. The first one is the configuration server, and this is the pull server. And who's used DSC and they've like run a DSC script on their machine? Yeah, good. Okay. So you go through this process, you compile the MOF file on your machine, and you apply it to your machine. And it's a bit confusing, but it's pretty straightforward. When you use a pull server, who's used a pull server, a hosted on-premise pull server? Yeah. So it's a bit more confusing. So what you have to do is you take your DSC script, which is your top PS1 file, you maybe take some configuration data, and then you take your modules, you have to send them all off to the automation account, to the pull server, and then that is where the compilation happens. It doesn't compile on your machine, or compiles on the actual server itself. The automation account, I think it uses a VM in the background to do the actual compilation. When we start looking at it, it's a little bit confusing, but and the automation account itself already has a number of PowerShell modules that it can use that are already hosted, but you can upload your own ones as well. These need to be compiled. Everything needs to be compiled. If nothing's compiled on the server, nothing will work. All right? So the main aim of a configuration server is just to compile DSC scripts. Yeah, everyone happy with that? It's pretty straightforward once you do it, but if you don't know about this sort of compilation step, then it's a bit confusing. Yeah, so PowerShell compile, not something that computes in my head normally, right? Yeah, sure. So with a DSC script, you actually compile it. So you upload the DSC script, and that is compiled from a DSC script into a MOF document, MOF document. And it's that MOF document that you're trying to create. The whole point of this is to get a MOF document. And the MOF document is everything we need to then deploy to a machine. Like DSC doesn't care about a DSC script, it cares about a MOF document. I don't know why. Just the way life is. So one thing to say is you have all your modules. These should be the same for all your environments. You have your DSC script. Ideally, that should be the same for all environments. And then your PSD is just configuration data. So you can have one DSC script that goes through each environment, dev, test, and production, and then different sets of configurations. You might have different connection strings, different settings, whatever. So it's quite useful. And then eventually your virtual machine, you can have your own machines pointing to automation accounts, but this is have a VM in Azure effectively that goes and gets the MOF file and uses it. And we'll talk a little bit more about how that works later on. So with a pool server, the idea is that you have your MOF file, it's compiled into a MOF file, so your DSC script's compiled into a MOF file, it's encrypted, and it is amazingly awesome. So the good thing about it is using this process, the encryption's handled for you, so you don't have to distribute your own keys, you don't have to manage any of the encryption yourself, which is really good, because these configuration files, these MOF documents, can contain sensitive data. They really you can have passwords in there, you can have keys in there, so you don't want everyone to be able to get them. So knowing that they're stored encrypted is a good thing. So I was going to do a demo in Azure, but then demos never work, so I just took a couple of screenshots. So has anyone seen the automation accounts in Azure? Yeah, roughly. So what this is a DSC script that's been uploaded like 4 or 5 times, and it's been compiled. Each compilation gets one of these little blades, and then if there's any errors, you just have to go to the logs and you see any errors, you see why it's not compiled. It's quite useful. Best thing about the Azure portals, finally we get to use the horizontal scroll bar that everyone's been desperate to use for years. If you don't use the horizontal scroll bar in the Azure portal, then you need to start using it. So what we have, so we've uploaded our MOF, we've got a MOF file, and the MOF file is effectively the configuration. Then a VM, you register it and it becomes a node and then in the terminology in automation accounts, you have a node, you have a config, and then you have the marriage of those, which is node configuration. It's pretty straightforward, but it's just the automation account has 3 sections, has nodes, has configs, has node configurations. So if you want to know which VM has been assigned to which configuration, then you just have to go into that. The second part to the automation account that we're interested in is the report server. And it's a lot simpler than the pool server. Basically, every time DSC runs on a machine that's registered to an automation account, it reports the status. It says, hey, I'm about to run a check. And then when the check finishes, if the machine's in compliance, it returns a success. If it's not, it returns a failure. So you've got one place you can go to, and you can see whether your machines are in compliance or not. It maybe something's drifted out of compliance, or maybe it's never deployed compliant in the first place. This, again, so in the Azure portal, so all of this is for automation accounts. We only care about these 3 parts. So we've got nodes, configurations, and node configurations. DSC nodes, this tells me, oh, look, there's a problem with this one. The machine's unresponsive. It's unresponsive because I turned it off. I think it's fair enough. So this here, it was purposely designed to fail. It's not an accident. So in Azure automation account, this is the reporting part of it. We can say, look, this machine's it's not consistent. It's not in a valid state. We can click on it and we can see why, and we see all the resources here. We've got 2 resources. One is compliant, one's failed. And as I say, keep going along this way. And eventually, over here, you get the details of the error of why it's not in compliance. That's really useful if you can't get onto the machine. So if the machine's in another environment you can't actually get onto, if the first step in your DSC script is to add administrators, if that fails, then you can't actually RDP onto the machines to see why they fail sometimes. So it's quite useful. It's quite annoying, like the UI is not great. The amount of times I'd do F12 in Chrome and then find this just to copy out the HTML, just to get to the actual contents of the error message. It happens quite a lot. But it's quite useful. There's a blog post here. I'll put the slides somewhere so you can download them if you want them. But this basically, blog post by Microsoft say these are the different options for reporting server, whether you've got DSC, whether you're using Microsoft Azure or not. And the top one is having a reporting server. And it really is good to be able to know when your machines are compliant, when they're not. You've got a single place to check. So sort of moving on a little bit, so we move to the actual VMs themselves. So in DSC, the whole point of DSC is that you're trying to configure this thing, the LCM. Has everyone heard of the LCM? Logical Configuration Manager. So forget about Azure. You just have a DSC script on your machine, you run it. What actually happens, and then you have to call that start DSC configuration. So what happens is your DSC script configures the LCM, and the LCM is what actually does everything. Until you sort of understand that it's like a sort of two-step process, it makes debugging hard and it makes things a little bit more confusing. But the LCM, that is it's like a WMI provider. It runs on like every half an hour, and you can get it, and it will check. Here we set the frequency to be every 30 minutes, and we check the configuration every 15 minutes. So you can have a different frequency for downloading. Checking, you might want to check every like 12 hours, 24 hours if there's a new configuration, or you might want to have it lower, or you might only want to check like once a week that your servers are active. It depends on your environment, depends how costly it is to check for data, check for changes. So in Azure, we've got a virtual machine extension, a VM extension that knows about DSC, and that can run a DSC script. We've also got an Azure Automation account, but the VM extension doesn't understand about the LCM, doesn't understand how to configure it. It doesn't understand how to tell the LCM on the machine to point to the automation account. So it sounds a bit odd, but what the VM extension does is you deploy the VM extension, it will run a DSC script, but it doesn't know anything about Azure Automation. So there's a sample on GitHub, which I've been using for quite a while. It actually works pretty well. It's pretty solid. And this will configure the local configuration manager, the LCM, to point to an Azure application account, automation account. So to deploy this and to get it running, what you do is you say to the DSC extension, you say, go and run this DSC script. This DSC script then configures the LCM, which will then, when it next runs, it will go and download the MOF file onto the machine and apply it. Right? It can lead to some strange things, a couple of like oddities. So what this is two machines. They were deployed at the same time. ARM was used to deploy the VM extension. In this case, on the first machine, the VM extension deployed and said it was a success, when actually the DSC script failed. And the second one, the DSC said it failed. So the first deployment worked and the second one failed. And the reason that this one worked was because the DSC extension was deployed to the machine, the script to configure the LCM was applied, and then the ARM piece of it checked the status, and it said, yep, I've run a DSC configuration, it's completed. But it was only the initial configuration of the LCM that completed. This stage hadn't started yet. Then on the second machine where it failed, what happened was the LCM was configured, then the actual DSC script was kicked off, and it sent a pending notice to the report server saying, I'm executing something. So then the ARM process then checked whether that had finished. It said it's in a pending state, so it kept polling and waiting till it finished. Then when it had finished, it failed, and it said, there's a failure. So that's why this one failed, and this one looked like it was a success. If it fails, it's guaranteed to be failed. But if it has passed, you still need to check the actual status of DSC and whether the machine's compliant as well, rather than just relying on that 100%. It doesn't happen very often. but it can happen sometimes. So I just wanted in this just to sort of talk about roughly the process for DSC and Azure. So it's like a 3-step process. So the first one is like your ops people, your dev people, you write some DSC scripts, you upload them to your automation account, they get compiled, they get published to the account server, and that's the MOF files, which again, they're encrypted. Then we use ARM to deploy the VM extension. That configures LCM, so that's the second phase. And then moving down to the last phase, the actual LCM downloads the MOF file, obviously decrypts it, applies it, and then reports backwards the state of it. It's this sort of 3-step process. Like any of these steps can go wrong, and any of these steps can fail. But if you've got this idea that it is a 3-step process, then it makes troubleshooting a lot easier. So moving on to troubleshooting. So if the first step fails, then in the automation account itself, it has the logs of why it failed. So the first thing I would do is I'll try and run the DSC compilation on my local machine. If it doesn't work there, it's never going to work anywhere else. So first of all, your developer should compile it. If you've got a build process, your build process should also try and compile it, make sure it compiles. And then finally upload it to the automation account and try and compile it. If it doesn't work, let's say there's an output log that says what the error is. If you've got the right modules in place, then it's normally success. There shouldn't really be any reason why it fails on the automation account if it works on your machine. If deploying a DSC extension ever fails, and this is pretty much for all extensions, if you go to C packages, there's a folder there for DSC extension, for all the extensions, and this has all their configuration, has all their settings and all their statuses. So if deploying the actual extension fails, you can have a look in here. It's pretty rare for the extension to fail. I guess the only time this would fail is if it had a problem downloading like the LCM configuration script, or if it had a problem trying to configure the configuration manager. Does anyone use like VM extensions in Azure generally? No one uses them. Well, I'd use them. They're quite good. If you want to configure DSC, they're quite good. Another good one is the domain join extension. That's quite good for joining a domain. Then you know when an ARM build's completed that your machine's already joined to the domain, which is pretty useful. Another useful thing is this. If you're on a machine, then DSC runs on a schedule. Like it will run every now and then, like probably 30 minutes, but you can't say I'll start at 1 o'clock and then run at 1:30. It'll just be at a time, run at 30 minutes. If you're trying to debug something, if you're trying to troubleshoot it, it can be a real pain trying to sit there going, right, I've got 30 minutes to wait, and you don't know exactly when it's going to kick off. If you use the start DSC configuration and you pass in use existing, it will execute whatever MOF file, whatever DSC script has been applied at that time. So this is useful if you want to have like any tracing, if you want to use like process mon to monitor anything at the same time, just do this. This is a real time saver. That's why it gets a little wow. If the applying the actual configuration, the DSC configuration fails, on the machine itself, Windows System 32 configuration and configuration status, it's got these JSON files, which are JSON, but they're good for reading in Notepad because they'd have Windows line endings. You don't have any silly line endings. The contents of these are sent to the automation account. So you can read these on the automation account. Depending what you're troubleshooting, it might be easier to read it here, especially if the logs are quite long, because the automation account is just get like one blade right at the end of the horizontal scroll, and the window's quite limited. This is quite an easy way just to have a look at the logs and see what's gone wrong. I guess this is sort of like DSC in general, really, but this is quite useful. And you need a good resolution because they go on for so long. Topical, obviously. So I was trying to find a picture that represented like the Holy Grail. So, and it's amazing what you can find. It generally is ridiculous. But it's everything to do with DSC, any config, if you want to have a look, see what MOF files are in there, any statuses are in this Windows System 32 configuration folder. That's the sort of the first place to look. Where are we? Right. So this is the actual folder itself. So this pending, this is the MOF file that's being executed at the moment. So when this was taken, a DSC process was running. It was taking like 15 minutes, and so it's set to pending. That's the previous one. So you can go back and see what the last one was. So because we use the VM extension to configure the LCM, which then went to pull down another one, this previous, you see it's slightly smaller, is just configuring the LCM. So if you had a look at it, you'd see that. You can't open these up because these are encrypted. If you ever get to the stage where you're like desperate to look inside an encrypted MOF file, it is possible. So as part of our build process, we had like variables injected at different points. So there's one issue I've had to look at it, and I was desperate to have a look inside it. I hope you never get into that state. But if you ever get into a state where you're desperate to look inside a MOF file, there's a couple of ways. There's a PowerShell function to do it. This isn't in the stand. There's this thing called DSC configuration module. That's got a load of helper stuff in it. This isn't in the published one yet. So what you have to do is you have to add a repository to like a dev build of it, and you add it. And what you do is you say unprotect the DSC configuration, and that will decrypt it and just output it to the screen so you can have a look inside the MOF file. Who's looked inside MOF files generally? Yeah. So I mean they're pretty easy to read. I don't think you'd want to write one from scratch, but they're pretty easy to read, and you can see your code in there. Being able to see the unencrypted one's really useful sometimes. As a second way, now I don't know, this isn't supported. I haven't seen any documentation about it, but if you go into the Windows temp folder, there's it's easier to see on new machines, but you get this like 16-digit number, and inside there you've got the MOF file that's unencrypted. As I say, there's no documentation about that, so I don't know if that will last forever. So I'd start using this one. Now, the Windows system, the Windows temp folder, you have to be an admin for, and to use this, you also have to be an admin for. So it's not open to the world. But if someone can get onto your box, then your secrets, you've got to have some sort of security boundary, haven't you? So that's sort of DSC really in Azure. And we just wanted to talk like a case study, like a mini case study. So we'll talk about, we've got a 3-tier application: SQL Server, App Server, Web Server. SQL servers, 3 clustered SQL boxes in an availability group. App servers and web servers, just individual servers. In this case, it's all vendor products. So there's an MSI installer for the app server, there's an MSI installer for the web server, just to make things a little bit harder. We do need to install things like IS, so we'll talk about that briefly. So the first step really in deploying the environment is some raw PowerShell, just native PowerShell, just to create the resource group, create the automation account, upload the MOFs, upload the resources, and then to remove any failed extensions. With the uploading the DSC script, one of the things is if you've got a lot of dependencies, a lot of modules, it was quite hard to say, like you've got to upload each one, wait for it to finish, upload the next one, wait for it to finish. So I wrote like a normal PowerShell script that uses like the AST stuff from PowerShell. If anyone use that, the syntax tree stuff, so you basically get a script and you turn it into a syntax tree of all the requests, all the things it's doing. So you go through, you pass the PowerShell script, your DSC script, get a list of all the modules that you need, upload all those modules to the automation account, compile them, wait for them all to finish compiling, then upload your DSC script, then compile that, and then the output to that obviously is your MOF file. Removing failed VM extensions. Everyone said they don't use them, but if you do use a VM extension, if you use ARM to deploy anything, ARM's like idempotent, so you just, every time you do it, it will go and fix it and make it right, make it so. But VM extensions don't. If they're in a failed state, they will always be in a failed state. So it's quite useful as part of the first step of your build. And this can be automated in TeamCity or something like that, TeamCity Octopus. First step is to remove any failed extensions. Then the second step is to deploy the ARM templates. So the ARM templates are for the virtual machines, like any infrastructure they require, like disks, NICs, whatever. For the SQL boxes, we use the SQL Server image, and I'll just talk about that in a little while. And then we've got the domain join extension and the DSC extension. Using ARM's pretty good for this because you can set up dependencies. You can say, right, we'll deploy the virtual machines, we'll deploy the domain join extension, and then once that's completed and we know the machine's on the domain, then we can deploy the DSC extension. It removes a lot of complexity that you have to manage in your DSC script. Otherwise, if you know, you're guaranteed to be on a domain at that point. Who's deployed SQL Server in Azure? Two people, three people, so not many. So when you deploy SQL in Azure, you've got a couple of choices really. You can either choose the VM image that Microsoft supply, or you can just get a normal Windows image and then install SQL yourself. And there's some DSC scripts to install SQL if you want. They're out there publicly available. We went with the option of using the VM image, and the sort of pluses and negatives really are, like first of all, everything's installed, so like we don't need SSRS or SSAS, so it's a bit of a pain, so you can have to like disable those services, but you do get SQL, you do get SSMS. Another sort of negative really is that the VM itself, the image itself, is patched by Microsoft on pretty much on a whim, and you can't tie to a specific version. So we had an issue, say we did a deployment, they'd updated the image to include like latest CU for SQL, then we wanted to install a later CU, CU4, and the install failed because the setup cache was corrupt for SQL, and the fix really was you had to either reinstall a service pack or you had another command line to run, and it's when you got to start building these things into your DSC script, it's possible, but it's all a bit more complicated and it makes everything a little bit harder. In the end, we raised it to Microsoft and they fixed it, and they did fix it within a couple of days. It didn't take them long to fix, to publish a new image out, but just be aware that if you do use an image, like one of Microsoft's images, that they will change, and they'll change and there's nothing you can do about it. So you've got to look at how important it is for you. But one of the main reasons for using it though is you get this SQLIS extension, which is great because it handles like patching for you, it handles backups to blob storage, you can configure it to do a whole load of other things as well. So it's sort of, this SQLIS extension is like a sort of mini DBA that Microsoft have given for free, so you don't have to get your DBAs to do stuff. Any DBAs in there? That's right, yeah, good. Right. This is like your happy, good mini DBA. It's not perfect, it does go wrong sometimes, but in our case, like the pluses outweighed the negatives of it. So the actual DSC script itself, so we've got quite a lot of stuff done outside of DSC. So within DSC itself, we set up things like regional settings, disk configuration, especially for SQL, you know, like strike disks and do that sort of stuff. It's quite useful. Install any Windows features we do need, like clustering support, setting up administrators. For the app and the web servers, there wasn't an image already available for us. But the vendor had sort of been aware of a problem of not having like a silent install, so they'd been working on a silent install for the application. It wasn't particularly straightforward. You'd have to run an MSI, the machine would reboot, and then when it booted up, you'd have to then log on, and then the second part of the install would sort of take hold and would carry on and finish it off. So we spent quite a lot of time figuring out like why is it rebooting in the middle of it, and then when it kicks off a second time, how does it actually kick off? And it's the reboot wasn't actually needed. It was just to clean up some temp folders, and then it uses like the run once key to do the install. So we just grab that. So as part of our DSC script, we do the first part of the install, grab the run once key, and then do the second part of the install. Does anyone work with like things like AppV? Anyone use that? So like for figuring out how to install things through DSC and stuff like that, the best people to talk to are these, your AppV administrators. If you search for AppV and images on Google, I'm 100% he comes up. And this is the win of the best AppV blog. So these are the people you want to get to know. If you take them for a beer, give them a hug. The closer you are with people who know about app virtualization, they will make installing applications a lot easier. When you talk about MSIs, you get things like product IDs and product codes, and they're like, yeah, I mean, you basically GUIDs, and you have to have exactly the right thing in the right place, otherwise it plays up, and they know all about it because they've been doing it for years and they love it. So there's a sort of a common like thing which you do. You should treat your servers like cattle. You shouldn't treat them like pets. And if you can, you know, it's going back to like the Docker thing. If you can run all your apps in containers, then yes, completely treat your apps like cattle. This is if you like, you can do the search yourself. You'll see it. We're not quite there really with, like, say this application is, we're going to have SQL Server, database, like a few terabytes for the database in an availability group. We're not at that stage where we can treat the servers like cattle. We've got to treat them a little bit more like pets, unfortunately. I think in 10 years' time, if we're still treating our servers like pets and not like cattle, I don't know, I don't think I can say that again, then I think we're doing something wrong. But for now, you can treat your servers a little bit like pets, pet-like. So, like the sort of the last stage really is setting up the SQL servers. It's creating the actual cluster, running the always on, setting up the availability groups, and then like some T-SQL. If anyone ever has to set up a SQL AG, there's this thing to do, like you can see, it's called seeding automatic, which is great because what happens is you copy a database onto one server, say now go and seed that other server, and it'll copy all the data over for you. Otherwise it's a real pain because you have to back up your database, take a log backup, restore it, get it to the right point in time. And if you've got that SQL IaaS extension that's also taking transaction log backups and sending them to blob storage, you then got to get all of those transaction log backups and restore them. It is a real pain. So the other A words is obviously awesome for this. So if you ever have to do it, just use this. Now, this part of it, you could put into DSC, and there are Microsoft-supplied DSC scripts for configuring always on and availability groups. For me, I think they're not quite ready and they're not there 100%. So if you have like a lab environment and you're a domain administrator and you set everything up, they do work. But when you get into other scenarios, perhaps you're not a domain administrator, you want to deploy to another OU or something like that, they start to not quite suit your needs 100% and they don't always work. So I think they're always being worked on, so within like a year or so, hopefully they'll be up to scratch and we can start to use that. And then, like this is the sort of, as going back to like treating your servers like pets, this is like an ongoing thing. So like this is sort of the first phase. We can take these and we can move them into DSC. We could take all of this and move it into DSC, but it's not quite there yet today. And the time it would take to do that outweighs the sort of benefits we'd have from it. So you just got to be a bit pragmatic in it. And so back like 10 years ago, we used to have that night out when we used to go to the pub. With DSC, you know, you don't have that necessarily, but once all your servers are deployed and you're happy, you can go to the pub and you can go and get drunk. So it's still good. So that's it. So, has anyone got any questions? Anyone know anything? No? Yeah, so you have one DSC script that you deploy to each of your environments, and you want to keep that DSC script the same because you can test it basically. But then for each environment you want to do slightly different things, so then you have your different configuration scripts for each environment. So you use the different configurations for each environment rather than a different DSC script. If you've already got a server set up that you can use, you might as well use that. Use the automation account, then you don't have to manage that yourself. So you can pass it off to Microsoft to have to manage. I'd prefer that, to be honest, but it's up to you. Okay, anyone else? Cool. All right, thank you.